Hello everybody. Good morning, good afternoon and good evening to one and all. Thank you for joining us for the KWS BEETROMETER event 2020. My name is Elton Carvalho. I am the BEETROMETER business manager at KWS and your host for today. As you know, the BEETROMETER is a very important development for KWS. And for this event, we have just a couple of tips. Firstly, if you have any questions during this event, please type in those questions. We will address all your questions during the dedicated Q&A session. Secondly, if you're experiencing any time lags or delays, kindly bear with us. We have taken our best effort to make it as smooth as possible. To invite you to this big event today, we have Mr. Jörg Phillips, the head of the Sugar Beet business unit at KWS. Over to you, Jörg.
Okay. Thanks, Elton, for introducing myself. Hello, everybody, and welcome to our BEETROMETER event. As Elton just said, my name is Jörg Phillips, and I would like to welcome you as partners from the industry, from the sugar industry, but also partners who have developed the technology with us, and also the members of the KWS family. As you are aware, we have a long tradition. So we are founded in 1856. So more than 150 years, 165 years, we are already working in research around the sugar beet. So sugar beet is our life. And we are very happy that we can work with this for such a long time. And you know, sugar beet is very research intensive. So we have done our best over the last 165 years to innovate via breeding, special resistances, and so on. And we are very happy today that we can discuss and show you the development on the BEETROMETER, which from our point of view fits perfectly into our innovation aspect, that we actually bring value to you as a customer and that help us to bring the sugar beet business forward, which has gone through various difficulties over the last years. But we think the innovation is really needed, and that's why we are very proud to offer this to you and to work this out together with you. BEETROMETER is a development which has taken more than 10 years. We have developed with partners, Polytech, for example, but there has been a lot of in-house investment and activities on that, and this is things which we would like to show you, especially Elke Hilscher, who's from KWS. Later on starting, we'll bring you more of the details, but also our partners, Puch and Polytech, will give you more insight. And finally, we end up with the American industry, who has already these instruments, BEETROMETER instrument, working. I have actually nothing more to say. I hope you feel well served with information. I actually hope for a very active interaction, that you participate and that we can bring our knowledge to you and that you are interested in the BEETROMETER and that this will bring us forward in the sugar beet industry. Thank you very much for joining. I hope everybody is on board now of the participants. We just had an increasing amount of participants, so enjoy the next hours and make sure you are interactive so you really take part and not just listen. That makes it more valuable for everybody. Thank you very much, and with this I would like to hand over to Elke Hilscher, who is just sitting beside me.
Hello everybody, good morning, good afternoon and good evening. My name is Elke Hilscher. I'm the leader of the chemical group as part of the research and development department at KWS. I will give you at first a short introduction about the development of the KWS BEETROMETER, what we have developed over the last years. At first, I will give you a short look, and if you see such a BEETROMETER looks like very simple. In the end, we have a conveyor belt, we have a special developed chopper, and we have the measurement system based on a near-infrared spectroscopy. But the system looks very simple, and so the system is also very flexible. And this allows us to make quality analysis in sugar beet about the value chain of the quality of the sugar beet. We have the analyzers on the field, such as BEETROMETERs installed since almost 10 years on harvester that allowed us to analyze sugar beets directly during harvest for the main quality components. As next, you can use such a BEETROMETER in a receiving station in a sugar factory, for instance, or in a quality lab of a sugar institute. Also, therefore, we have respective calibrations. And last but not least, you can use such a BEETROMETER also on a mobile system, on a trailer, for instance, and can, with this system, analyze stored beets. And we have respective calibrations for washed beet, for unwashed beets, for fresh beets, and for stored beets. The development of such a system has any challenges. The most important challenge is the heterogeneity of the quality components. And if we look in the first, sorry, this was my mistake. The next advantage is of our BEETROMETER, it can mainly short the steps in the analyzers. In the normal way, in the sugar factory, we have the delivery, then we take a sample, we have the washing process, the thawing process, pre-processing, preparation of the filtrates, and the analyzers. With the development of the KWS BEETROMETER, we are able to replace any important steps. So we have, of course, the delivery of the beets, and we have the washing process of the sample, what we have taken, but all the other steps are completely replaced by our KWS BEETROMETER. And now I come to the most challenge if you develop such a method. The most problem is what I said, you had an irregular distribution of quality components within a beet. We have done a special trial 4 years, 5 years before, and have analyzed the different segments of a beet, what you see on the left side, different colors, and the segments marked different content of sugar. And you see, we have alone in the head of a beet and the tip of the beet a variation of sugar content of up to 3%. And if we then look in the middle of a beet, then we have here, if you look outside of a beet and in the center of the beet, a variation of sugar content up to 2%. The next problem what we have not this irregular distribution of quality components within beets, the same as also between beets. As an example, from a uniform field, more than 450 samples were taken with a sample size of round about 12 beets. And we had a very high variation. We seen in the middle we had round about a sugar content of 16%, but we had a variation in the single samples between 13.5 and more than 17%. It means more than 4% between the different samples. Then the question is that I got all the time is, if you compare your results of the BEETROMETER with a typical price sample, how big is the difference? Then I ask you as an analytical scientist, what is the real value from the sample? For instance, we have the delivery of 25 tons. From this 25 tons, we take a subsample of around about 40 kilogram. We make our pre-processing, then we take a subsample of 26 gram, and in the end we make an filtrate, and we use only few milliliters for the analysis. What we know from the analytical point, the biggest error comes from the sampling step itself. It means the first sampling is if we take a subsample of 40 kilogram. And the next problem comes with the sample preparation, pre-production. Pre-production is such an important process. You have to include all parts of the beet, and you have to include all beets of a sample. In the end, if you do this in the right way, you have round about 1.5 kilogram of a pre. And in the end, we take only 26 gram of this pre and make our analysis. And from the whole filtrate, what we produce in the laboratory, we use then only few milliliters. That is, with each sampling step, the susceptibility of errors increases. If we think on the application of near-infrared spectroscopy to develop a method, then we have to think on the sample preparation, since we have the irregular distribution of quality components within and between beams. We have to think on the measurement of the whole sample and need an homogenization of the sample. And last but not least, we need multivariate calibrations for the prediction of the quality components. As we in the beginning of the development, what we have seen from previous analysis with NIR spectroscopy, all of this work were based on a dry sample, and this is clear, since the production and the sample preparation of a dry sample is a well-known approach and a well-accepted worldwide method for sugar beets. The problem is it's the right one for a subsequent wet analytical chemistry, but the problem is that such a dry sample is not stable. We have a high instability, and what happens if you produce such a dry sample within few seconds, you have a change in the color from like white to dark brown. And we have not only a change in color, we have also immediately this beginnings after processing, we have an influence of the sugar content. The main problem is of such a dry sample, this is very wet. It's clear our sugar beets consist to 75% only of water. And what happens is you have a very fast development of a thin liquid phase on the surface of such a dry sample. And if you then respect the rules of near-infrared spectroscopy, you know the near-infrared wavelengths are completely absorbed by water. It means NIR light is not able to penetrate through water. So if you make a measurement on a dry sample on the surface, you analyze only few microliters of the liquid phase. If you put your dry sample, for instance, in a cup from glass and make then a measurement on the bottom, then you analyze also only few grams. So it was clear, to the application of near-infrared spectroscopy, dry is not a solution. Therefore, we have developed a special shopping system, and this allows us to process to between 15 to 150 kilograms of beads in only few seconds, and we have included in this processing a mixing and homogenization steps of the samples. We have no liquid phase on this shop beads, and this is important, the next one. And since this works so fast, there is no oxidation and browning before the measurement of the shop beads. This was the basis to develop the method for near-infrared spectroscopy. Today, we have a uniform sample presentation and pressure roll produced from all the shop beads and even surface. We can analyze the whole sample. There is no further sampling step inside, since the whole sample and the shop beads of the whole sample are moved under the sensor. And in a distance of 200 millimeter to the sample surface, every 40 milliseconds, a spectrum is scanned during the shop beads are moved under the sensor. So in the end, from a sample size of around about 40 kilograms, we have more than 400 spectra that were analyzed in 15 seconds, and the whole process, including sample preparation, takes 20 seconds, not more. This was an overview about the work process of the BEETROMETER, and now I will give over to my colleague, Elton Carvalho.
Thank you, Elke, for this wonderful presentation. Weren't you impressed by this? This took a lot of time, 10 years of hard work, yeah? Well, this makes my job as a business manager so much simpler. Well, because a good product sells itself. Say, assume, like me, you were equally impressed with Elke's presentation. You trust KWS as a reliable partner within the sugar beet industry, and you want to move forward to the 21st century. What would be the advantages for you? The first advantage that you would have is the BEETROMETER is a complete system. It's an industrial unit that is ready to be used. It can be installed within an existing house. It can be installed in parallel to your operations. Initially, of course, you need to win the trust of your farmers that this system is giving you accurate results. We have the possibility of installing this system in parallel to your existing system, and thus you are able to compare results and win the trust before fully transitioning into this system. The second advantage of this system, again I want to highlight, the technology behind the system is very complicated, but from the design, operation and maintenance perspective, this is as simple as it gets. There are few moving parts, it's robust construction, it's easy to operate, and it involves minimum maintenance at all points of time. And finally, it does the job for which it has been built. It gives you accurate results. In fact, every sample of beets that is tested has a minimum of 400 readings. That means one reading every 40 milliseconds. KWS over the years has over 5 million samples collected. That means we have accurate calibrations for all kinds of beets and can give you accurate results in 20 seconds only. So it serves your need. But then, a lot of you will ask, we have our existing systems for the last 10 years, 20 years, sometimes 40 years. Why do we still need to change? Here's why you should change. We have studied this system and we have tried to improve it. With automation, we have few human errors and sampling errors. The entire process is standardized, thus giving you reliable and accurate results. The second point that we have done away with is the use of chemicals. A lot of these are highly polluting and need specialized workers on a seasonal basis to handle them. And then this also leads to a lot of maintenance costs. With our NIRS system, we do away with all these requirements. The third point, agronomy. What happens with existing systems, because of the high cost of testing, we tend to reduce the amount of testing, sample testing that we do. Here we say, go in for more testing, get accurate results and reward the farmers who bring in beets with high recoverable sugar content. This improves agronomical practices within your farmers and improves the overall efficiency of your factory. Because when you have beets with high recoverable sugar content, you have a more efficient factory. And the final point, KWS, as Jörg has already mentioned, has been in business for 160 years. And with the BEETROMETER business, we plan to be here for a long time too. That means every year the calibrations are upgraded into your system. All new features are updated via software update. And we have a very robust system which will run for years. To learn more about who will build this system, I introduced you to Mr. Martin Herman from Puch. Puch is an old name in the sugar industry with very reliable results. They are the manufacturer of this BEETROMETER. Over to you, Martin.
Thank you very much, Eldon, for the short introduction from your side. Also from my side, I would like to send a warm welcome to everybody listening to this session here, which is actually the first digital BEETROMETER event. Because unfortunately, starting from next year, we are facing a lockdown once again. So today, I will present to you the Puch Tearhouse solutions. But before I start with that, I would like to spend a few words on the Puch company. So Puch company is a private company owned by the family Radinger and was founded in the year 1871. So that means starting from next year, we are celebrating our 150 years anniversary. And of course, with a lot of new products and process solution, we are going to introduce to the industry. So I hope you will follow next year what we are presenting. And today I would like to start a little bit from the tearhouse and also from the beet sampling, actually with a project which we of course did together also here for this part with KWS, because there's a new factory in Egypt, which is located approx 250 kilometers south of Cairo. Is a canal sugar project. Beet slicing capacity of this new beet sugar factory will be 36,000 tons. The beet receiving part in beet washing and even of course the tearhouse sometimes also should be designed for 48,000 tons max. The bead receiving of this new factory will be 24/7. There is no bead storage foreseen. Actually, up to 120 bead samples per hour we need to process. Bead sampling we do in 2 lines, you will see. So then, of course, as we do it in 2 lines, because of this huge amount of sampling, we do it with double washing machines for each line. And of course, and we are very happy about this, we introduce the KWS NRS system, the BEETROMETER, for the efficient analyzing of the beads. So with the next slide, you see the concept of the bead sampling lines as a 3D model right now, because the factory is still under construction. Of course, we have considered 2 bead sample lines. So each line, of course, is capable, yes, of processing 60 tons per hour. We have here 2 driveways. Then, of course, we have the traffic lights for the exact truck positioning before, of course, the bead samples enter the tear house building. Having a closer look to the Putsch tear house system, of course, the beads will be going to the slide and into the funnel first to the gross scale. Then, of course, this will be led to the double chamber washing machine. Of course, we can decide which side of the machine there's a slider installed we are using. So then, of course, we have a perforated belt and, of course, the topping machines if needed or if applied. Then, of course, we have a single bucket elevator with a net scale integrated, which makes it very easy. Then, of course, we go into the BEETROMETER unit, and we have only installed, this is very interesting, 1 BEETROMETER unit for the whole samples. Of course, we do the complete automation and software. Of course, you can see that also later on in a short video presentation. Here is only a screenshot of the control system which we did. So you can, of course, really online monitor all the steps and all what we do. And of course, each sample is of course with an ID. So you can easily track each sample and of course evaluate immediately within minutes. So important for the bead sampling, of course, and this was actually also the first start when we got into this business, is actually that we saw bead sampling only picking either in the front part of the truck or maybe only more in the middle part. So we divided the truck trailer load into 9 sections, as you can see on the right hand side. And of course, so this allows, so this random selectively bead load. So for the picker, so really to select the samples, so either, so from the front or in the end or from the middle part and really close to the side walls. The bead sampler itself, of course, is a little bit modified to the designs you may know from your factories or from Venema design. But also, of course, today is a very sturdy design made out of 3CR12 or Hardox material. And even, of course, the whole pipe where the beads are in there is a special coated material. So the bead sampler, of course, is capable, like we also saw in the previous presentation, to pick up 40 kilograms of beads. With the next short video, you can see, of course, an old bead sampler in operation, because what we do also, if you are interested in upgrading your old system, that we of course do the complete software automation and also hydraulic upgrades for the automatic bead sampling. So you can see here that the bead sampler, even with the strap, or with the steel bar there, of course, is not touching that and is really going straight to the side wall of the truck. Of course, we also divided this into 9 sections, very easy control. The push automatic washing machine. Now here, of course, designed as double washing machine. Of course, we also provide a single washing machine depending on the capacity. The bead washing machine, of course, is designed for high pressure wash. So we can apply water pressure with the jet nozzles up to 15 bars max. So usually, of course, we see that a range of 8 up to 9 bars are sufficient for a good cleaning result of the beads before it goes onto the inspection conveyor. Of course, as I said, yes, so this inspection conveyor, yes, so has some holes in it for drainage. Then, of course, we collect the drainage, yes, so in a container, so that, of course, no water or dirt is splashing around the area. So at the end of this unit, of course, we took that design from KWS, but of course we also redesigned this unit as a very compact unit. You can even see here on the picture that the bead chopper together with the NRS system is installed on rollers, so it's easy movable. Of course, we also have now installed here the HMI touchscreen for the local control. It's either attached to the unit itself or somewhere else, depending on local conditions. The bead chopper, of course, which is a KWS design, is equipped with so-called chopper hooks, which is a forged design and very sturdy design. So, and of course, here you can see a 4-shaft design, depending how much kilograms, of course, of beads we need to process. We also have a 2-shaft design available. So you can see here with the NRS system that we have, of course, a swiveling head, really, of course, for this leveled and also compacted bead layer, which is also done by a pressure roll, which you can see later on also from the American installation. And of course, this swiveling head, of course, really so can measure the whole bead layer. So this is, of course, from my part. So thank you very much for your attention, and I give back to Elton.
Thank you, Martin, for the wonderful presentation. As you know, KWS works with the best partners in the industry. We have Puch as the manufacturer of this BEETROMETER, and over the last decades, I would say, not even years, but decades, we have worked with Pulitech, the manufacturer of the spectrometer. And to present to you more about this spectrometer, we have Dr. Linas Urbonas. Over to you, Linas.
Hello, everyone. My name is Linas Urbonas, and I'm a business development manager for process analytics at Pulitech. And it's a great pleasure to give you an overview on our near-infrared spectroscopy instrumentation for industrial quality control applications here. Besides various optical measurement technologies, Pulitech provides near-infrared spectrometer systems for material testing in routine analytical and industrial manufacturing applications. So such an instrumentation is dedicated particularly for real-time 24/7 operation and chemical analysis of incoming materials, monitoring of manufacturing processes, or final product quality control. So already for more than 20 years, we are successfully working in this field, providing our established technology for countless industrial applications. As I mentioned already, Pulitech provides spectrometer systems for many industries and applications, starting from agriculture, feed, biotech, chemical, pulp and paper, and many other industries, up to those where really strict regulatory requirements should be fulfilled, like pharmaceutical or food industries. So talking about various industries and applications, as one good example here, I can mention our close and successful cooperation with KWS that lasts also since almost 2 decades, where we target some seed breeding and industrial process control applications, by developing and commercializing dedicated products and solutions like BEETROMETER that we are presenting you today. So now let me briefly explain how this BEETROMETER part, where the measurements are done, or in general, how near-infrared spectrometers work, how one can get precise and immediate results. The principle behind is pretty simple. Actually, it is based on optical spectroscopy, the technique used to investigate how the light interacts with a material of interest. With a certain broadband light source, the sample is illuminated, and then this transmitted or reflected light is split into individual colors, so-called wavelengths. This response curve is called spectra, and such examination is done in near-infrared spectral range, which is above the visible range that we see with our eyes. Since every material consists of different constituents, different molecules, the absorbed light is also differs accordingly. So chemical information of the investigated material can be evaluated from such a spectra. The quantitative information of composition of the material is defined by analyzing the position of these absorption peaks. So each material will have different spectrum and therefore different number and position of such a peaks. And qualitative information, so concentration, telling how much specific substance is in the material, is analyzed by looking at the height of these specific peaks. In general, such a near-infrared spectroscopy has some advantages compared to the conventional laboratory analytics. No sample preparation, so no chemicals are required. It is non-destructive and non-invasive technology. It is really fast. It allows to make the measurements in real time and also directly at the required location. It is representative. All the samples are measured and not only a small fraction or small subsamples. And of course, the corresponding decision can be made faster since all the results are immediately available. The NIRS for BEETROMETER setup consists of three main modules. Sensor head, where the illumination and light collection takes part. This unit is installed over the conveyor. Then the spectrometer, where the reflected from sample light is dispersed and detected. And finally, the industrial computer with corresponding software, where the recorded spectra are processed and measurement values are calculated. So now let's have a closer look at a sensor head. Using such a distant sensor head leads to several advantages. So the measurements are non-contact and non-destructive. The sensor is quite compact, so it can be installed easily in various lines. It is robust. It has no moving optical or any other sensitive parts. It has integrated light source with automated system referencing. And finally, such sensor can be installed over moving samples or conveyor belts to gather representative measurements from all the material passing by and not just a small subsample. So here you can see several photos from such a sensor head installations above conveyor belts where measurements on samples are done. The spectrometer itself is based on a high-end optical setup with a holographic rating and diode array detector. This brings the following advantages. Again, robust industrial design, superior optical performance for more light throughput and sensitivity. This leads to that really fast measurements can be performed. One measurement lasts a fraction of a second. And at the end, such a fast system allows to measure the samples in movement, so more material can be analyzed. Finally, we offer real-time process software with industrial computer and corresponding interfaces that transfer the data and can communicate with various industrial control and data storage systems. So such a flexible, but at the same time robust, fast, and precise spectrometer system can be easily integrated in a new or already existing arrangement or processing line for reliable measurements and quality control applications, like, for example, BEETROMETER. Thank you for your attention.
Thank you, Linus, for the wonderful presentation. Now that you have seen the presentations from KWS, the manufacturer Puch, and our industrial partner Pulitech, we would also want to show you that every BEETROMETER unit that is manufactured undergoes a rigorous factory acceptance test. So here it is for you, the factory acceptance test, a short video. Hello, my name is Elton Carvalho. I'm the BEETROMETER Business Manager at KWS. Today we are going to conduct the factory acceptance test on the BEETROMETER unit at Puch, the manufacturer of this unit. Come along. During this test, we check the BEETROMETER for robust construction and design, smooth mechanical operations, safety features, software integration, and finally, calibration and accurate measurement. Today's factory acceptance test was successful. This BEETROMETER will be delivered to our client Canal Sugar in Egypt. To learn more about this system, please feel free to reach out to us. For the next stage of this BEETROMETER event, we take you across the Atlantic to our colleagues in the US. We have Mr. Dwayne Bernardson live from the American Crystal Sugar Company. The American Crystal Sugar Company is one of the first customers of the BEETROMETER. Over to you, Dwayne.
Hey, thanks, Elton. Thanks, everyone, for joining. Happy to be able to be part of this event while we're bringing you the remote part from here in North America. I'm joined with Mitch Kennedy, the Quality Lab Superintendent at American Crystal, and we're sitting on the dock at the Quality Lab, so we're right in the heart of the full operation. Harvest got done a little early here at American Crystal. They had good weather, but we want to be able to show you how the system works. So we put together a short little video that will take you through the BEETROMETER in action here at American Crystal. So let's play that video. We put together a short video of the BEETROMETER installation at the American Crystal Sugar Company Quality Lab in East Grand Forks, Minnesota. They operate 6 identical lines, with each line being able to measure tare, whole sugar, dry matter, and recoverable sugar. After washing, the beets are weighed again clean so that the percentage of tare can be calculated. The scale opens directly into the BEETROMETER chopper, where the sample is processed. Once chopped, the sample is collected on the belt below until enough material is ready to be prepared for measurement. The belt moves the sample under the roller, where it is leveled and compacted to maximize the area for good scans. From there, it passes under the sensor head, where a scan is taken every 40 milliseconds. These scans are then filtered, averaged, and a prediction for each calibration is saved, along with all the spectra data. A quick, easy, and reliable process. So Mitch and I just want to talk a little bit about the system here. As the video mentioned, it talked about how the measurements they had used at American Crystal. American Crystal has been using a quality payment system since back in the 1980s. And at that time, they went to a wet digestion measuring pole sugar, sodium, potassium, amino N, and to get their recoverable sugar for their payment, because their growers are paid for how much white sugar they as a grower are able to put in the bag. This is the second campaign that the BEETROMETER system has been used here at American Crystal. So I guess before I answer the question, I just want to make sure everyone knows we're practicing good social distancing here and following through. That's why we don't have the masks on. But Mitch, would you share an overview with your lab and the process you use here?
Yeah, thanks, Dwayne. Good morning, everyone. So what we do here, as the video said, we run 6 identical lines with the KWS BEETROMETER system. Annually, we run about 190,000 samples, split into 2 different time sections. Typically, during main harvest, we'll call it, we run 15,000 or so a day. But like I said, we do divide it up into two sections. We call it pre-pile and a main stockpile harvest. Pre-pile runs from about mid-August to the end of September. We typically take about 10 to 15% of the crop, which equates to about 2.5 million tons. We can do this on 1 to 3 KWS lines. We do about 8-hour shifts. And that runs, like I said, till about the end of September. And then starting October 1st, we do main stockpile harvest. This, we just run until we're done, till all the beets are taken out of the ground. We run 24 hours a day, 2 shifts. Typically, we have about an hour downtime to do any maintenance, clean up. But like I said, we run 2 shifts. The goal for the day with this new system is to clear the dock, we call it. With the old wet digestion, the goal was to not fall behind. But with this new system, we can run samples quickly, but we are still accurate, reliable, and consistent data. So we call it clear the dock, which is impressive when you consider on good days, we can harvest over 1 million tons of beets, which equates to about 15,000 samples per 1 million tons. So, you know, at the end of the day, it's to provide the most accurate, reliable, and consistent results for those growers, those shareholders. So,
yeah, and it has been, it was really nice this year for as fast a harvest as you had. That you, I know for you, it felt good being able to get in and clear the dock. So how did your campaign go for you this year, Mitch?
Campaign this year went as well as could be expected given our current world situation. You know, COVID really it contributed staff-wise. The last 2 harvests were difficult harvests. So it kind of created a compound effect on our staffing. We did have people not feel comfortable in coming back this year just because of COVID. But our goal was to create a safe and safe environment for everyone. And I think we did accomplish that. As you said, we had a very quick harvest. We had typically you could run out as long as October and in November. This year we were pretty much done in 14 consecutive days. So October 14th, we were pretty much done. We ran about 180,000 samples, pre-pile and stockpile harvest combined. But overall, things went very well. The nice thing about a quick harvest is you can push the equipment and see how everything works, and things worked wonderfully this year. So very happy with this year's results.
Yeah, Mitch, you bring up a good point. That's one thing we talk about. COVID, we compare with all of our colleagues across the world as far as that situation, and in the U.S. COVID has actually been similar across the U.S. beet production areas. We're listed unfortunately, in a hotspot here in Grand Forks right now, and I know it's similar for other people, and you brought up some good points as far as how you were able to manage that situation. And just help the comfort level. I think that was a big part. One thing you talk about, or you mentioned, you use a lot of temporary help,
Yep.
and you know, with running 2 shifts, I think that can prove a little bit of a challenge at times.
Yeah.
So I know your day crew is more of what would you say, your veteran crew? Or?
Our day crew is our veteran crew. Yep.
So you have some people that have a fair amount of time in here as far as working on the quality lab.
No,
side.
those individuals typically have anywhere from 15 to 40 years experience. So those individuals really help out the process. You know, as you said, COVID has proved difficult, but with the new system, you know, some of the thought that went into that is we could reduce the temporary staff we need. We really didn't get rid of anyone per se, but it reduced the temporary staffing we did need because it was beginning to get very difficult to find help. COVID kind of compounded that. So, you know, the new system, you have less people working, but you can also be spread apart. So that really helped the comfort level of those individuals that were here. And that was a big benefit. Maybe not one that you intended to have on any normal year, but you know, it was a great benefit this year.
Because how many staff do you use now, and how did that compare to what you had before?
This, we typically, on a normal year with this system, we'd have about 65 harvest employees compared to over 130 for the wet digestion, the old way of doing things. So it cut it roughly in half. But, you know, with this, you know, on the inside, we call it, roughly 4 to 5 people per line. Now we can do 1, if not 2 per line. So it really helped things out on the social distancing aspect.
Yep, and I think, you know, that brings up the other point is people talk a lot about automation and how automation, you know, with automation, you're able to reduce people. And it's one thing I know you guys have said, you've reduced people, but really you still are those highly skilled people that you've been able to maintain those and keep them on, which helps you. One of the questions we, you know, always comes up as well is how does it go on the grower side? The growers feel comfortable with the data you're providing them, and what sort of questions do you get from the growers in regards to that?
You know, as you said earlier, this is our 40th year of the quality lab payment system. So we've had 40 years of trust building, which really helps during this transition. You know, and there's a lot of research, time, and effort put into switching over. Just to make sure the results were reliable and consistent compared to our old way of doing things, and things were very consistent, and that really helped being transparent with all the growers. You know, the most questions we get aren't even about the quality per se, it's about the tear conditions. You know, why is my tear high? And we were able to implement a new feature which put conditions with each beet. So that really helps with those questions, but you very rarely get questions about sugar content, recoverable sugar. So they are pretty comfortable with the results we get.
And just for people, if you haven't heard, I know we have a video about the system as well that's on our BEETROMETER website with American Crystal and kind of that transition. We worked hard to work with you as far as calibration. We continue to work on the calibration to keep that current. So one of the things that you do is look at the beets from around the area, where different production areas, where they come from, and we kind of take those through. So we keep that calibration that's live, and I think that as well has helped you as well as management feeling that the system is reliable and good results.
You know, as you said, it's a living, growing thing. So you keep adding to the calibration, and it keeps getting better and better. So yeah,
so you have one line here, like you said, we've used that, and it's really helped bring that comfort. We did work, especially with our first installation, making sure we put together a line so that we're able to compare. It's really hard you can't split samples, so it's working through that process. Elka does a really good job in helping us understand that and get through that as well. I mean, if we look at some of the other benefits, I think we talk about labor. I think the other side is probably sustainability.
Yep.
I mean, how do you feel? You got a system when you compare the system you were at, which I think that was one of the fears was sustainability of the wet digestion. How do you feel on the BEETROMETER system now?
I am very happy with things. It's some of the questions you get are maintenance. The old system, you have a lot of variability with that system. A lot of moving parts, a lot of things can break down. Your KWS system, mechanically, it's a lot simpler, I guess we'll call it, in a way. There's a lot less moving parts. So the maintenance aspect, it's reduced that. So that's a huge benefit. Just on downtime alone, our old system, you'd have to calibrate every 30 minutes. With your KWS, you still calibrate every 30 minutes, but it's for 23 seconds compared to minutes with our old system. And, with your system, as you can talk, you're kind of calibrating with each sample. You have your confidence factor, which you can go into if you'd like. But I'm very happy with things.
So just to kind of clarify, Mitch talked about the calibration. They do a reference sample every 30 seconds, which really takes in the potential changing environment of the system. One thing that probably hasn't came out, we haven't pointed, is they run 6 lines. So we bring those lines in and we do a bias adjustment so that it provides that confidence that each line is reading accurately and really giving you the same information for each. And I think that was one of the benefits that you saw as well. So I think we've probably hit our time here. I want to make sure that we have some times for Q&A. So Elton, we'll go back to you and you can help us lead us through that Q&A session.
Thank you, Dwayne. That was wonderful. Thank you, Mitch, for your insights as well. We seem to have a lot of questions from the audience, and thank you so much, everyone, for this active engagement. We will start off with a few questions for Mrs. Elke Hilscher first. Elke, the first question for you is, how does oxidation of the brine sample change the sugar content?
Yeah, this is what happens if you produce a brine. Then you have immediately starting also the sucrose inversion. This is what we has watched over years, and we notice. Then okay, in the first 5 minutes it's not so big. You have a loss of around about 0.1% of sugar, but it happens.
All right, thank you very much. The second question that comes in is how much green matter, the tops from the sugar beets, can the BEETROMETER cope with?
This is the big advantage if you have a reliable calibration. Since the calibration, how should I explain? Look for some information in the NIR spectra, and then we can differentiate, comes this information from the sugar content or comes from the chlorophyll content, for instance. And so it has no influence.
All right. The third question coming in is, can the BEETROMETER measure non-sugars?
This is a very interesting question. I stand not here and say, yes, we can measure sodium and potassium. From the physical law, it makes no sense. What I can say we have a look on all organic components within a sugar beet. In the normal way, we analyze only 12% from all non-sugar components that may have an influence of the recovery of sugar in a sugar factory, for instance. Here with our BEETROMETER, we can look in all organic components. This include also pectins, for instance. They have a big influence on the recovery of sugar and many things more.
All right, thank you, Elke. The next question coming in here is, how critical is the washing quality and the chopping quality for the NIRS analysis?
Thank you, that's a good question. The chopping quality is the same. This is a standardized approach, and there are no differences between the different kind of beets. If there are dry conditions or wet conditions, the chopping quality is all the time the same. You are right, the washing quality has an influence, but therefore we have developed two different calibrations, and we have, during our measurement, we have some quality issues that shows us if the calibration is adapted to the conditions, and then we can switch between a calibration for more or less unwashed beets and a calibration for washed beets.
Perfect. And another question, which might be linked to the earlier question, is how does the beetrometer measure in the case of root rot or some remaining leaf matter, which is...
Yeah, this is also a very good question. In the normal, this has no influence. We can clearly see that that we can analyze the sugar content in all the time in the right way. Of course, if the infection has an influence of the sugar content, then we see this. Then we have, for instance, with SBR infection, then we have a lower sugar content, and with the BEETROMETER we detect this lower sugar content. But in the end, the infection itself has no influence on the precise and the accuracy of the sugar content results.
All right. The next question is very interesting. The question here is as follows. We are an integrated sugar factory. We process sugar cane and sugar beet on the same diffuser, but the cane can be shredded and the beet is sliced and chopped. Yeah. Can we use the BEETROMETER for both?
Yeah, good question. I noticed that the sugarcane industry is using since many time the NIR spectroscopy. It's not so new for them. And for the sugar factory, or the sugar beets, this was the problem since all the investigations were based on a price sample in previous. I'm not sure that we can shop the sugar cane with the BEETROMETER. I'm pretty sure this may not work, since this is not more in cutting with knives, and I think for chopping the sugar cane you need more knives. What we are doing is here we broken more the beets as that we have in cut of the beets.
All right, and one last question for you, Elke. In your presentation, you said we need about 45 kilos of beet samples. Can we measure accurately with less than 45 kilos?
If you have seen the presentation from American Crystal, you see they have smaller sample sizes. We have around about 20 kilograms, and then we can adapt the system. We have a smaller shopper and a smaller conveyor belt. We can do this.
All right. Thank you very much, Elke, for your time. I think there are a couple of business questions which I should address directly. One question, of course, is can we visit this BEETROMETER and see it in operation? Yes, you are welcome. We have an in-house BEETROMETER in Kleinwansleben. If you are in North America, you are welcome to contact our colleague Dwayne Bernardson. He is in charge of this business. He would be more than happy to show you. We have another BEETROMETER being installed at Canal Sugar Project in Egypt. So we are definitely happy to show you the BEETROMETER in operation. And yeah, of course, in the US, the US market, the system is slightly different, and the manufacturer is different, etc. But we can adapt, like we said, we can adapt the system to your requirements. I think for the next set of, there's also one more question for me. Sorry, I just have an update. And the next question is, what does the BEETROMETER cost? Of course, big question. For that, get in touch with me, you know. We will make you an offer. We will work on with you. We are happy to speak to you, explain to you how the system works, try and understand how you have worked until now, and then adapt and make you an offer customized to your unit. We can assure you it is much cheaper than the other systems, but you need to ask me or Dwayne in North America, all right? For the next set of questions, we go over to Mr. Martin Herman from Puch. Martin, are you live?
Yes, I am.
All right, Martin, here's the question for you. You spoke about the washing machine. Our customer or a potential customer asks me, or asks you rather, how much water does the washing machine consume?
This, of course, Elton, depends, of course, on the washing time you apply and also on the washing pressure, because I told you, so we can apply a pressure of up to 15 bar. Usually we only work in a range of 8 to 9 bars. Washing time, of course, can be set from 1 minute to 2 minutes, depending on the soil and dirt attached to the bead. So let us say if we really calculate the maximum values, we say it's approx 800 liters per washing cycle. Yeah, so with 2 minutes washing time.
All right, perfect. The second question is also very specifically to your presentation. And if you have a completely new installation for sample taking, like the one you had in your presentation, for analysis using wet chemistry for calibration, can you offer this as well?
Yeah, let us take what we actually presented. Yes, so for this alkanal sugar project, we also do that. So we can send labeled samples, yes, to the nearby Aldoran factory where they have a traditional lab installed, and of course they can do also, yes, so traditional measurement, yes, and calibration as well.
All right, perfect. Martin, thank you so much for your answers. I think the next set of questions are for our colleagues from the US. So Dwayne and Mitch, are you ready?
We're ready. Thanks, Elton. We're here.
All right, here we go. The first question to you is, if you put the sensor head over the belt, that is over the BEETROMETER belt, how do you track back the delivery to every individual grower? Because how does this translate into the payment? How do you manage this?
Yeah, Mitch, maybe you want to step through just quick how you record your sample tickets from the, maybe even start just from the piler, and what your process is there.
So when the beet truck comes in, it gets weighed and then it goes to the beet piler. At the beet piler, they take a sample from about the middle of the truck and they put it in a black sample bag, which I don't know if you can see, but there's a few
hanging in the back,
hanging in back there. With each sample bag, they have a associated sample ticket that is given at the scale house that gets put into the bag, and then it comes here on the dock. We hang the bag, and then at the in scale where it gets weighed the first time, they take the sample ticket out, they scan it, and then it gets put into the computer, and that sample ticket associates with that sample. So as it moves through the process, every station, all the weights that are associated with it associate with that sample ticket. And then after it gets scanned, all that data is associated with that sample ticket. So everything comes back to the scanning of the barcodes on each sample ticket.
And just to add to that, a good point, that was a good question in regards to that, because another good point was that was a real pain point in the old wet digestion system as your samples were on the beet wheel, having to keep track of that sample ticket. Whereas now with the BEETROMETER system, the SCADA keeps it as it goes through. You're able to see each spot where it is. Once it hits the system, it's you know, they're tied together right away, and it's off. Whereas when you had that beet wheel, you had a lot more samples you had to keep track of, and it's really been a good trouble-free system there.
The new system greatly reduces variability. So,
anything else, Elton?
All right, perfect. Thanks for that answer. Yes, of course, we got a lot of questions for you guys. I think you did a... All right, the next one is as follows. How often does the BEETROMETER need calibration? And is this done with a regular chemical process each year?
Yeah, so the question in regards to calibration, and Mitch and I were talking a little bit about this after we got done. So we work together. It's one of the things Elke kind of talked about or touches on as well, is that, and how we refer to it is, we refer to a calibration being a live living thing, and working with that. So we work with American Crystal to make sure that the calibration for their system is updated annually. And maybe we kind of have a little a teamwork that we work together. Maybe Mitch, you just want to talk a little bit about what we do. The calibration's updated before the campaign each year, but maybe what we do to collect those samples as we go through the year.
Yep. So we do field samples. Typically, we run those on the old line, and then we take those results, and we add them in to the calibration at the end of the year, like you said. And then during the year, we do take samples from various locations, and then we just run them on the comparative line along with the KWS line. So you get those results, and those are also added in at the end of the year for the next beginning year. So it's a living, growing thing from year to year.
And we've been talking about, you know, sustainability is a big thing. How do you have a system that's sustainable? That was a big challenge with the old wet digestion system. And this is a process that we're working through as well, as how do we develop that sustainable system? And as everybody becomes more comfortable in how things go together, what we can do to do that and reduce, even reduce a little bit more some of the things that need to be done so that we keep that calibration live current, because the questions come in, different growing areas, things in that, different years, different varieties.
Yep.
So we really work together in how we can do that, as well as having the advantage of our field trial group and all the research samples that we're able to do worldwide at KWS. So you say you have more, Elton?
Yes, I do. I certainly do. Actually, this is a follow-up to your last question. And this is, can you just throw some light? I think people are worried. They just want to understand how often is this analysis and needed, a wet chemistry analysis needed to make sure your system is accurately calibrated. So how many times in a year do you do it, or how, like the frequency? They just want to understand the frequency of this or something like that.
So the question was, sorry, just trying to make sure we hear it's how often do we do this calibration process, or what we do? Yeah.
How often you need it or something like that.
Okay, for the wet chemistry. So I think the one thing to clarify is calibration is only updated once a year, so you stay with that same calibration. And so what we do is, as Mitch mentioned, we actually put together a schedule, and we maybe try to collect brine samples, say once a week or once every couple weeks.
Yep.
Isn't that, wouldn't you say that's
Yep,
what we did?
that's accurate.
We've done some stuff early on, because that question that came up, like Elke asked about the smaller sample size as well, just working with that, you having a smaller sample size, making sure that things are accurate. You get such variability with the brine. So that was one of the things, just having that comfort level, and I think we've reached that. But what would you say? We collect samples every other week, maybe?
Yeah, I would say every other week. You know, and what people really need to understand is each year is going to be different. You know, different soil samples, different varieties. So as long as you can keep adding, it's going to keep on getting more accurate. You know, that not saying that it wasn't, but it's, like I said, it's a growing thing. So given more samples, more time, you know, it's the better off.
And that was an advantage when we came in right away. We had 10 years, as Elke said, we had over 10 years in our KWS calibration. So we worked with our KWS calibration, and Elke and her group really fine-tuned that with the chemistry, with the process in your equipment, so that it was a good seamless transition from using your wet chemistry results to our NIR results. There was a good seamless comfort and transition with that. Hope that answered that, Elton.
Perfect. Thank you so much, guys. That was wonderful. All right. Thank you very much to our colleagues in the US. And now we have one last question. Actually, we are already running out of time, but we will take one last question for Mrs. Elke Hilscher. And the question is, in one of your slides, Elke, you mentioned that you can measure the total nitrogen. Would it be possible to measure specific nitrogen compounds as well?
This is also good questions. Yeah, this is right. We can measure total nitrogen, especially in the area of a sugar industry where we have a big variation. Total nitrogen, this is a high content in a sugar beet of more than 1%. The problem is if you go to specific nitrogen compounds, as for instance betaine, then you know they are less than 0.2, 0.1% inside of a beet, and therefore I must say, therefore NIR is not possible to do this. I say only things what we can save and nothing else. Of course, I can show you calibration, I can do this, but in the end, in the validation, it will be broken.
All right. Okay, sorry, we have one more still just come in, and you have to address this one last question.
And if there are any questions outside of this, please, Elton,
I will do that.
We are here.
All right, perfect. Thank you very much, Elke. Thank you everyone for joining us today. This was really wonderful having all of you. Katrin, our marketing manager, just mentioned to me that we had over 100 participants from around the world. This was really fantastic. As you can see, myself here and Dwayne. Dwayne is in charge of the business in the entire North American market, and myself in the rest of the world. So if you have any further questions, just feel free to reach out to us. We have personally emailed you before this event, and we would be more than happy to address any of your issues. Until then, like we said, be ready to move to beet quality analysis for the 21st century. Good afternoon, good morning, and good evening once again, and have a nice rest of the day. Thank you.